We are doing lesson 37 in Algebra 2. Actually, excuse me, lesson 38 in Algebra 2. Okay. So, what we're going to talk about is let's look at x squared. We know what that means. Doesn't that mean x times x? Yeah. Just like this is equal to this times that, because everything inside this parentheses is squared, which gives us x to the 8th, y to the next 6 is e to the 4th. Now let's look at this next one here. It says you have two terms raised to the second power, so it basically means 2x squared plus 3y times 2x squared plus 3y. Well, we're now multiplying binomials or polynomials. This means times right here. So what we do is we take the first one times the first term, 4x to the 4th, this times the second term, which is 6x squared y, just like we're doing long multiplication. Then 3y times 2x, so we kind of do it in a different order. We go backwards. And then 3y times that. And then we add them together, and this is what we get. So that's all that means. So let's look at another one. If it tells us to expand x plus 3 cubed, doesn't that mean x plus 3 times x plus 3 times x plus 3? So the first thing we want to do, we'll multiply the first one together. And we get x squared plus 6x plus 9. And I did this in my head, but basically what you're doing is you're taking x times the first term, x times the second term, plus 3x, and then 3 times the first term, and 3 times the second term. And you combine like terms, you have x, and you get x squared plus 6x equals, or plus 9. Now, so that was only two of them. So now I want to do x plus 3. Again, I do x times the first x cubed, x times 6x plus 6x squared. Can't forget, when I multiply, I'm not adding, I'm multiplying. So x times x is x squared, my exponent rule. X times 9 plus 9x. And don't forget, there's a minus. You've got to keep that minus with it. 3 times x squared is plus 3x squared. 3 times 6 is 18x plus 27. So we have x cubed plus 9x squared plus 27x plus 27. And that is simply your answer. There's nothing else you can do. Alright? So when it's raised to a power, it's everything inside there times itself that many times. If this was to the 5th, you'd have 5 of those, and this would be 3, and you would do the process again, times x plus 3. That would be 4, and then times x plus 3. Or we know that this is 2 of them, so we can multiply this times itself, times another x plus 3. So it's just long and complicated. That's all it is. You just got to keep track of what you're doing. Moving on, so we're going to talk about solving by factoring. So we said 4 times some number equals 0. It's going to be what? 0, yes? So if the product of two factors equals 0, one or both have to equal to 0. Because of that, we can come up with a zero-factor theorem, which says if p and q are real numbers, and if p times q equals 0, then either p is equal to 0, or q is equal to 0, or both are equal to 0. Okay? Why do we need this? Well, this helps us when we factor and we're solving. So we've got negative x plus x squared plus 6. We want to solve for x. Well, first thing I'm going to put in order x squared minus x plus 6. We said, equals 6. So I'm moving the 6 over and equal it to 0. Then I'm going to factor x minus 3 times x plus 2. And if you don't remember how to factor, we can talk about that in class, and briefly, we'll talk about that in class if you're having trouble factoring. So just make sure you let me know. So now I've got the product of two numbers. Even though they look complicated, it's still a product of this and this equals 0. So I said one or both have to equal 0. So I can simply say x minus 3 equals 0, x plus 2 equals 0. And I can solve for x plus 3 plus 3. So x is 3 and x is negative 2 are my solutions or my roots. But I have to check them and make sure they work. So I put them back into my original equation. So I'm going to do here, negative 3 plus 3 squared equals 6. Negative 3 plus 9 equals 6, and 6 equals 6. That checks out. Let me try negative 2. Negative 2 plus negative 2 squared equals 6. So that's negative 2 plus 4. Did I do that right? Did I put the right solution back in? Oh, I forgot. This is negative 2. So that becomes 4 positive 2, excuse me, 2 plus 4 equals 6, and you have 6 equals 6. That checks out. So both of these are solutions, a root. So the zero factor theorem can be extended to the product of any number of factors by saying that if the product of two or more factors equals 0, then one or more of the factors must equal to 0. So let's look at one. Let's look at another example. Let's look at example negative 35x equals negative 2x squared minus x cubed. So I want to get everything to one side. So I'm going to move this to that side. So I get x cubed plus 2x squared minus 35x equals 0. So I'm going to factor out an x. Remember, we have to get the greatest common factor first. So I'm going to factor out x. And I'm left with x squared plus 2x minus 35 equals 0. Now I can factor this to be x times x plus 7 times x minus 5 equals 0. And like I said, if you're having trouble factoring, we will go over that in class. Now, because of our extension of the zero factor theorem that said if you have the product of two or more factors, then at least one of them must be equal to 0. So we're going to set them all equal to 0. So this one is already solved. Minus 7, x equals negative 7, x equals 5. And I did this in my head. I did it really quick. So our solutions are x is 0, x is negative 7, and x is 5. So we've got to check our solutions to make sure they're right. So we go back and put 0 into here. So each one of them has 0, so 0 equals 0. So we know that one works. Let's try negative 7. So I'm going to cheat and use the book. Negative 35 times negative 7 equals negative 2 times negative 7 squared minus negative 7 cubed. Alright? The book does the calculations for me, so I'm not going to do them. I'm going to rely on the book. Negative 5 minus 125, you have negative 1, I think this says 50. I've got a misprint in the book. So negative 175 equals negative 175, so that checks out. Now I've got to check on, oops, I did the wrong thing. Sorry. 245 equals negative 98 plus 343, and you get 245 equals 245. That one checks out. And if you look at the book, they put 5 in, and that one checks out. So they're all solutions. Now, however, let's look at example 38.c. where you have okay, 2x squared plus 4x minus 70 equals 0. Well, I'm going to factor out a 2 of each one, so x plus 20x minus 35 equals 0, and it simply gets 2 times x minus 5 times x plus 7 equals 0. Well, here, it's a little different because I can set this one equal to 0 and this one, but 2 can never be equal to 0. So we can't say that 2 is a solution. So the solutions are going to be x equals 5 and x equals negative 7 only. Not 2, because you put 2 equals 0, it's not a true statement. So only these two are solutions and not that one. Alright, so do your practice problem. That is it for this lesson.